over here. And I know this is just the diagram, so I'm going to walk through the different questions that it does ask you. So we can notice in our diagram, it's not even going to let me move it, is it? Oh, there. Okay. We notice right away in our diagram that it gives us a couple of different forces acting upon this. It doesn't take a genius to figure out what these forces are. They do provide us with I'm getting the notes up. They do provide us with some of these measurements. I'm going to be writing them down to the side because it did not paste the question, because it would also paste the answer, which we are not doing. They give us the angle phi, which will equal some value. They give us the length, which again is some value. They give us the height, which again, some value. Okay? Make sure, you guys, you convert this into meters. Make sure that this is in meters. Make sure that this is in degrees. Okay? Always be careful of your conversions. The first thing that they want us to find is T1. So let's find T1. T1. How can we find the equation for T1? We can do if we were to call this point, maybe not that color. Change colors. If we were to call this point B, and if we were to call this P, as it's already been called, this right here is H, and this right here is L, then we're going to get the following equation. The summation of forces, okay? Always go for a summation equation. The summation of forces at the point, it's going to equal T1 sine phi L, so multiplied by L in case that wasn't clear, minus T1 cos phi times H. So over here we're taking the length, right? We're taking the length because we're taking it respective to point B, the length and the height. So we're taking the vertical and horizontal components. And then we're going to also subtract WL over 2. What in the world is W? It's the weight. W is the weight. How do we get the weight? It should give you either W is equal to some value, or big, or they're going to give you the weight. What am I saying? They're going to give you the mass. I forget which one it was. Which is going to, then you multiply it to get W, which is equal to W divided by gravity, right? And that's how you get W. And then you are going to go ahead and plug that all in. If you were to rearrange this equation, I'm not going to rearrange it fully, but it's T1 sine phi L minus cos phi H is equal to WL over 2. You rearrange that, plug in all your equations. Remember, this just becomes divided by all of that. Okay, there's no way I'm going to rewrite that, but it becomes divided by sine phi L minus cos phi L. Okay, you plug that in here, and your T1 value should be less than or equal to around 10 if you have numbers relatively similar to the ones I got. Don't freak out if you don't. I'm not going to give you guys my numbers, but don't freak out if you guys don't. But it should be something around that for those of you guys on your last attempt. Now, to find the second force, which is T2, this little baby right here, what we're going to do actually is we are going to set up another summation, except this time it's going to be summation in the y direction. Why? Because look, this is T1. T1 is at an angle. That's why we have to take the horizontal and vertical components of it. T2 is completely in the vertical. So we can take the summation of Fy, forces in the y direction, which again is going to equal 0 because this is not moving. It's at equilibrium. I know I didn't state the question, but it's not moving, which then we're going to get the equation T2 minus W plus T1 sine phi. And then you can solve for T2. So T2 would be equal to W minus T divided by, actually guys, we're not doing the rearranging. What did I do? I don't know. I'm confusing myself. We move the negative W over there. Guys, why am I confusing myself? T1 sine theta, that becomes, so this becomes W over sine phi. Nah, it doesn't. I'm wrong. Guys, my brain is barely functioning at the moment. This becomes W minus T sine phi. What in the world was I thinking? I have no idea. Okay? That's just because you flip the equations. This becomes a positive, that becomes a negative, and then you should be able to get T2. Okay? T2 should be also relatively small, so greater than or equal, less than. Guys, I messed up my sign. See, that's what I mean by my brain is working at the moment. This is equal to, okay? Again, if you guys don't get that value, that could be because you guys have different numbers. This is just how you guys, the general way of solving it. I think I'm going to put a purple around here just to show you guys where the final equation is. The final equation. And honestly, guys, I use this as it is. I literally plugged it in as it is to find the equation. Minor readjustments. Now, how do we find, the last thing that it wants us to find is this force P or force F, whatever you want to call it. And this is completely in the horizontal. So we can do the, I don't want to do purple. I want to do black. We're going to do the summation of Fx, so the force in the x direction, which again is going to equal 0 because this is at equilibrium. You're going to do T1 cos phi minus F, because these will balance out to equal to 0. And then you can solve for your F. So your F becomes F is equal to T1 cos phi. And that should give you your answer.